In this video, we're going to solve the polynomial inequality that you see there. The first thing we want to do is get all the terms onto one side. Now, what we want to do after that is make sure that we can factor it, and that'll allow us to do interval testing. Well, we see that when we plug an x value of 1 into that polynomial, we get a value of 0. That means 1 is a factor, and we go about doing our synthetic division. Now, notice that I have a 0 in the placeholder for the x squared right here. You always have to make sure if there's a term missing that you have that placeholder. Well, what we figured out is that we really have x minus 1 and then x squared plus x minus 20 is less than 0. We can factor that trinomial, and we have x plus 5 and x minus 4 is less than 0. Well, we're fully factored, so we're in a good position to make our number line and put the zeros of that factored expression in order from least to greatest, left to right. Now, what we're going to do is we're going to pick a number to the left of negative 5 in that first interval. So suppose we let x be negative 6. If we let x be negative 6, then x minus 1 is negative 7, x plus 5 is negative 1, and x minus 4 will be negative 10. Now, is negative 7 times negative 1 times negative 10 less than 0? Absolutely it is. So what we do is we put a check mark in that column. Now we can then proceed to interval 2. We pick a number in that interval. Let's say we pick the number 0. Well, 0 minus 1 times 0 plus 5 times 0 minus 4 less than 0 is what we're testing. Is that true? Well, negative 1 times 5 times negative 4 is 20. 20 is not less than 0, so this entire interval is not going to be giving us a valid solution. Okay, good enough. So now we proceed to the next interval, and we can pick a number like 2 and plug it in. Now, what some people find, remember this is the where we're testing, what some people find is it's a little bit quicker for them if instead of actually evaluating each bracket, they just determine the sign. So the first factor is x minus 1. If x is 2, x minus 1 is positive. If x is 2, x plus 5 is positive. And if x is 2, x minus 4 is negative. Well, would a positive times a negative be less than 0? Yes, it would. And finally, when we go to interval 4, we pick a number greater than 4. I could pick any number, let's say 100. 100 minus 1 is positive, 100 plus 5 is positive, and 100 minus 4 is positive. Well, is a positive times positive less than 0? No, it is not. Now, we started with a polynomial inequality, and we only have a less than sign. We don't have less than or equal to. So because of that, we know that these values here of negative 5, 1, and 4 will not be part of our solution set. So our solution set is going to be the set of all x element of the reals such that x is less than negative 5, that's that first check mark, or 1 is less than x is less than 4, and that's that second check mark. And if we want to put that in interval notation, it would be negative infinity to negative 5 in union with 1 to 4. If you're not sure whether to include the values of negative 5 or 1 or 4, just take a moment and actually test one of them. So let's say we let x be negative 5. If we were to let x be negative 5, negative 5 minus 1 would be negative 6. Negative 5 plus 5 would be 0. Negative 5 minus 4 would be negative 9. And we would be testing if that's less than 0. Negative 6 times 0 times negative 9 is 0. So we'd be testing is 0 less than 0. 0 is not less than 0. So that tells us we should not include negative 5 in our solution set, and we didn't. So the answer is the part that is boxed in with a star next to it. And I hope that was very illuminating for you, and I'm going to press stop.